I am Mohammed Ismail. In this module, I would like to share an outline on the synthesis and properties of furan, a heterocyclic compound. Heterocyclic compounds are cyclic hydrocarbons that contain heteroatoms such as nitrogen, oxygen, phosphorus, etc. Heterocyclic compounds are superior than typical cyclic hydrocarbons because of their unique property and versatility due to the presence of heteroatom. The presence of non-carbon elements such as nitrogen, oxygen, sulfur induces notable applications of these compounds in pharma and agrochemical industries. Quinolin, a bicyclic nitrogen containing compound which has drastic effects of anti-inflammatory, antibacterial effects, and it is also used as a flavoring agent, preservative, and colorant in medicine. Dihydroxyquinoline, a drug which contains quinoline molecule, is used for curing intestinal in- intestinal infections. Similar to this, there is a heterocyclic compound which contains oxygen named furan. It is a monocyclic compound which contains five-membered ring in which there are four carbon and one oxygen. The overall molecular formula of furan is C4H4O. The name furan is being derived from a Latin word furfur, which means bran. It is a naturally occurring substance from which the parent product of furan, perfurol, is derived. As far as the synthesis of furan is concerned, it is synthesized from perfurol, a naturally occurring product. It is it is highly present in pentose, wheat grains, etc. The structure of perfurol is depicted in the presentation, which on oxidation in presence of potassium dichromate, a strong oxidizing agent, yields 2-furoic acid, which on further decarboxylation, that is the emission of CO2, yields furan. In a similar manner, in substitute to potassium dichromate, silver oxide also oxidizes perfurol to perfuric acid, which on further decarboxylation yields furan. Paul and Knorr, scientists, synthesized furan from 1,4 dicarbonyl compounds. They took 1,4 dicarbonyl compounds where the carbonyl group is present at the first and the fourth position of the compound, which on dehydration yielded furan. As far as the physical properties of furan is concerned, it is a colorless liquid which is highly flammable and volatile in nature. The boiling point of furan is 31.3 degree centigrade and has a melting point of minus 85.6 degrees centigrade. They are highly soluble in organic solvents such as acetone, ether, alcohol, and etc. But they are partially soluble in water. As far as the chemical properties are concerned, furan acts as an aromatic compound. Basically, Huckel's rule is an applied to check whether a molecule is aromatic or anti-aromatic or non-aromatic. According to Huckel rule, a aromatic compound must possess a cyclic planar compound and it should have 4n plus 2 pi electrons. For example, if 1 is substituted in the place of n, we get 6 pi electrons. On applying Huckel's rule in furon, it is observed that it is a cyclic planar molecule and also it possesses 6 pi electrons. It contains two pairs of pi electrons and a lone pair of electrons present on the oxygen molecule. Hence, it is concluded that furon is an aromatic molecule. Also, furon undergoes electrophilic substitution reactions. The electrophilic substitution occurs at the C2 second carbon position of furon. It is because when electrophilic substitution occurs at the second carbon, it yields three resonating structures, whereas when the electrophilic substitution, that is the electron-loving species, attack the furon ring at the third carbon, it yields only two resonating structures. More number of resonating structures indicate that the molecule is more stable. Hence, the electrophilic substitution at the second position is more feasible than the third position. Certain electrophilic substitution reactions are nitration, sulfonation, and as follows. In nitration, furon reacts with hot sulfuric acid in acetic anhydride, gives 2-nitrofuron, where the nitro group is attached to the furon ring at the second carbon position. In this reaction, acetic acid is generated as a byproduct. Similarly, on sulfonation with sulfur trioxide and pyridine, furon yields furon 2-sulfonic acid. This reaction occurs at 70 degrees centigrade. Gattermann reaction is formulation of aromatic compound. Usually the aromatic compounds reacts with hydrogen cyanide and hydrogen chloride in presence of Lewis acid catalyst such as AlCl3 to yield aldehydes. It is highly used in the synthesis of salicylaldehyde and other compounds. Similarly, furon also undergoes this type of reaction known as Gattermann reaction. Furon reacts with hydrogen cyanide and hydrogen chloride in presence of Lewis acid catalyst to yields perfurol. It is the product from which furon is synthesized. The product can also be regenerated by reacting the furon molecule with these reagents to get the furfurol. And the other form is halogenation. Direct halogenation of a furon is not possible because when furon reacts with the halogen molecules such as bromine, chlorine, it yields hydrohaloacids such as hydrochloric acid, hydrofluoric acid. Hydrofluoric acid is not usually possible, hydrobromic acid, etc. In order to prevent the formation of a hydrohalous acids, furon is converted or oxidized to furonic acid. Then the bromine molecule is made to react with the furon molecule to yield 5-bromo 2-furonic acid. As the furonic acid substituent is attached at the second position, the bromine molecule gets attached at the fifth position. Therefore, the molecule gets a name 5-bromo 2-furonic acid, which on further emission of a carbon dioxide on heating yields 2-bromofuran, as the molecule does not possess any substituent in the second position. The bromine molecule attached to the carbon is considered as the second carbon, and therefore the name 2-bromofuran is given by IUPAC. The other reactions of a furan are basically oxidation and reduction. On reduction, the furan molecule will give dihydrofuran, where the double bonds present in the furan ring will be absent and only a cyclopentane ring with oxygen atom present. Such type of reaction is known as reduction.